Hi guys, I'm Norman Ignacio. This presentation is all about the discussing of the lateral and longitudinal stability. The discussion are followed by this scenario, the CG24 forward and the CG24 AFT, and lastly, uneven fuel loading or consumption. Number 1, the CG24 forward are discussed by Mr. Dieter Gutierrez.
A serious problem caused by CG being too far forward is the lack of sufficient elevator authority. At slow takeoff speeds, the elevator might not produce enough nose-up force to rotate, and on landing there might not be enough elevator force to flare the airplane. Both takeoff and landing runs will be lengthened if the CG is too far forward.
Now, the second discussion is the central gravity too far off, and we will discuss by Alison Hilario.
I'm Alison L. Hilario. I will discuss to you the scenario center of gravity too far up. Based on our research, balance control refers to the location of center of gravity of an aircraft. This is primary importance to aircraft stability, which determines safety in flight. Both lateral and longitudinal balance are important, but the prime concern is longitudinal balance, that is the location of center of gravity along the longitudinal and lengthwise axis. As long as the center of gravity is maintained within the allowable limits of its weight, the airplane will have adequate longitudinal stability and control. If the center of gravity is too far off, it will be too near the center of lift, and the airplane will be unstable and difficult to recover from a stall. If the unstable airplane should ever enter a spin, the spin could become flat and recovery would be difficult or impossible. I download some videos that tells you more about this center of gravity is too far.
This free flight training tip is brought to you by ForFlight, the leading producer of aviation apps for the iPhone and the iPad. Check them out at forflight.com. All right, what you're looking at here is a picture from the Pilot's Handbook of Aeronautical Knowledge showing how a typical aircraft balances in flight with the center of gravity and the lift and the downward force produced by the horizontal stabilizer and the elevator, so your tail down force. A student recently emailed me saying that, it was a little bit surprising about the tail down force. That was kind of new information, and also had some questions about what he'd heard online about how if you move the CG aft, you'll get better true air speeds, better fuel burns, you'll have lower stall speeds. And so what we're going to look at today is just a little bit of flight mechanics to try to understand why that stuff happens. It may be counterintuitive, but all that stuff is true. Now, we hear a lot during private training, and we're going to bounce over here to one of my drawings. You're going to have to bear with my art, but I'll draw while we talk. But we hear a lot during private training, how dangerous it is to load the center of gravity too far forward or to load the center of gravity too far aft. And we are going to remember that anything out of limits is bad. But what we're talking about today is within limits. So, our main wing here produces an upward force. And that's always, in the aircraft we fly anyhow, that's always behind our center of gravity, which has a range. You can, put it anywhere in this range. An aft loading would live somewhere here. A forward loading would live somewhere here. And the tail is producing a downward force to balance these two downward forces. All right, and that's what I'm going to show you, that if you put your center of gravity forward, you've got a longer arm here and a stronger pitch forward moment. Okay, so the force down here is actually stronger than it would be if you'd loaded your CG aft. And what that requires then is an increased tail down force to balance that stronger pitch forward force. And you need to actually compensate for that in lift. So an aircraft that is flying with the center of gravity that's loaded forward is actually, and the air is flowing something like this, is actually flying at a higher angle of attack. Okay, you're actually flying at a higher angle of attack, and that's why you've got lower true airspeeds, you're burning more fuel, and if you can imagine that an aircraft like this has more apparent weight, right? So it doesn't matter if you've actually got lead bars in the plane or if you just push the center of gravity forward and create an apparent weight. Either way, you've got to compensate for it here in the tail. You've got to add that to the total lift produced, and that's why you stall at a higher speed with a forward CG as well, because the aircraft is effectively heavier. So we're always going to load the CG within limits. We're not talking about loading outside the forward limits or outside the aft limits, but we are pointing out that with an aft CG loading, you will have higher true airspeeds, lower fuel burns, and lower stalling speeds.
And lastly, I will discuss the uneven fuel loading or consumption. The lateral balance can be upset by even fuel loading or burn off. The piston of the lateral central gravity is not normally computed for an airplane, but the pilot must be aware to the adverse effects that will result from a lateral unbalanced condition.